In this section, we're going to talk about some words that sound very similar to each other, and we're going to need to really pay attention to how those words relate to each other and the fact that those words aren't exactly saying the same thing, even though they're kind of looking at the same phenomenon from different angles. And the notion here we're going to talk about is divisibility. We're assuming a and b are two integers where a is not equal to 0. The following statements are equivalent. In other words, we're introducing some terminology and seeing which of A and B plays which role. So we say A divides B. A is a divisor of B. A is a factor of B. B is a multiple of A. And B is divisible by A. All 5 of these statements mean there exists an integer q such that b is equal to aq. This definition is really important to remember. One of the things that I mentioned in class today was that you should consider pursuing 3 levels of understanding definitions. The first level is just remembering it, putting it on flashcards, remembering exactly what the definitions say, so that you have that clear and solid in your mind as you try problems, do proofs, etc. Level 2 is thinking of examples, generating examples of that definition. So for this definition, level 2 would look like, 3 divides 12 because 12 is equal to 3 times 4. In other words, the integer q here is the 4 in this equation. That's level 2 of understanding a definition. Level 3 is trying to take it generally and seeing how to apply that definition in different contexts. The most commonly used of these items in the list up here are these 4. So those are the ones you should definitely know the most. And remember that they all relate to this definition. Pay very close attention to where B is in each of these statements and where A is in each of these statements. The other thing to keep in mind is that these are statements, these are propositions, they're things that whose truth value we can determine. They are not calculations, and I'll elaborate on that more as we go further in this description. So we say A divides B if and only if the remainder is 0 when B is divided by A. Look at this equation, think back to the division algorithm. What's missing? It's the R. In other words, the R, the remainder, is 0. So it's consistent with what we're saying here. Instead of saying these statements in words all the time, we have a shorthand for it, which is this notation here. A, vertical bar, B. But the way we actually read this is A divides B. It's really important not to use a slash of any type because you're not doing A divided by B. And I'll elaborate on that more in a moment. This A divides B is a statement. Okay? If we want to say A does not divide B, then we put a little slash through the vertical bar. So back to this idea that we should not confuse the statement A divides B with the expression A divided by B. A divided by B, or A over B, is a fraction. It means take A and divide it by B. It's a calculation. That's not the same as this statement, which is true or false, depending on what A and B are. When we say A over B, or A slash B, that means A divided by B. It's a calculation. We're doing division. For example, 11 over 4, we think of that as some fraction that we can calculate and we get a number answer, which is 2.75. That's not the same thing as what we're saying here. A divides B. Okay, so the words divides, divided by, you have to make sure you understand the difference between them. Again, the definition, going back and putting things together that we've talked about so far, when we write it more symbolically, we say A divides B if and only if B is equal to AQ for some integer Q. Again, level 1 would be memorize. Level 2 would be come up with some examples. Level 3 would be figure out how to apply it in different situations and as generally as possible. We have that A and B can be positive or negative, and B could even be 0. For us to make A not equal to 0, well, think about it. If I said B equals 0 times Q for some Q in Z, the only thing that B could possibly be is 0. So it's kind of weird to say 0 divides 0. I guess technically by this definition it's true, but in fact 0 is equal to 0q for all q in z, which is weird. It's not consistent with this definition, but we'll leave that alone for right now. And we'll focus on some examples that are a little bit easier to understand. Yes, we could say something like 3 equals 2 times 3 over 2, but I want to remind you that we're trying to stay in the world of integers right now. We're trying to express everything in terms of integers. Even when something doesn't divide evenly into something, we have the division algorithm to give us a way to express it completely in terms of integers. So yes, even though there exists a rational number or a real number in general, such that 3 equals 2 times that number, it doesn't make sense to say 2 divides 3 in this context, because we have to have that q be an integer. For example, 14 equals negative 2 times negative 7, which tells us that negative 2 divides 14, is a true statement. So now what you need to do is read this hands-on exercise, pause the video, give it a try. It is officially part of your homework, and you're practicing with a definition. You're practicing applying a definition to these numerical examples. So this is kind of like a combination of testing you on level 1 and level 2 of getting this definition and working with this notation. Remember that you can apply the division algorithm to these pairs of numbers, and so you'll be able to find the quotient q and the remainder r, such that b is equal to aq plus r. And remember that in the special case where a does divide b, you have that the remainder is going to be 0. In other words, we're layering on what we've been learning in previous sections with what we're learning here.